Hi guys, welcome to 9-2, arithmetic sequences and partial sums. So an arithmetic sequence is a sequence whose consecutive terms have a common difference, which we call d. So if you have a sub 1, a sub 2, dot, 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 a sub n, if there is a number d such that a sub 2 minus a sub 1 equals a sub 3 minus a sub 2, which equals a sub 4 minus a sub 3, etc., which equals the same number d, then that sequence is an arithmetic sequence. So if we asked you to find the common difference of the following arithmetic sequences, here we go. It's been a long day already. So if you had 5, 8, 11, and 14, it's as easy as it looks. Your d is just, okay, well, what's 8 minus 5? I don't have to check every single one because we already told you that it's an arithmetic sequence. So 8 minus 5 is 3. That's your d value. For b, if you had 15, 11, 7, and 3. So again, pick any two consecutive. You always take the second one that you choose minus the first. So if I did 11 minus 15, d in this case is negative 4, and that's okay because that's just adding a negative number, which is fine. So I want to show you how we derive this what's called nth term formula. So we know a sub 1 would equal itself. A sub 2, to get that second term, you take a sub 1 and you add that common difference to it. A sub 3 is taking the term before a sub 2 and adding that common difference. But remember, I'm trying to derive an equation for you to use. By substitution, we know a sub 2, right, from above, is really a sub 1 plus d. So I just substituted that in, plus this d that was already there. So really, a sub 3 is just a sub 1 plus 2d. A sub 4, the same idea. That's the previous term, a sub 3 plus d. Again, you want to use substitution. We know a sub 3 is a sub 1 plus 2d, plus this d that was already there. So really, a sub 4, great, I'm getting a call. I'm going to, just always something. Where was I? Okay, so a sub 4 is the first term, a sub 1 plus 3d. And you could continue doing this, but hopefully you're seeing a pattern that the a sub n term is a sub 1 plus n minus 1 times d. So like for a sub 4, it was 3 times d, so that's n minus 1. 2 for a sub 3, that's n minus 1. So this is a formula that we will be using throughout the section. There's not a lot of notes for me to go through today, which is good news for all of us. All right, so for number 2, if you had one like this, find the nth term of their arithmetic sequence. Great, now I have a voicemail. You can't make this up. With common difference 5 and first term 9. So really all we're looking for you to do here is to take your equation, where you have a sub 1 plus n minus 1 times d, and this is just really as straightforward as just substituting it in. Of course yours won't be this easy, but so a sub 1, what are they telling us? First term is 9, so it's going to be 9 plus, gosh, just so popular today, and my common difference is 5, and we do want you to simplify this. So a sub n, that's going to be a 5n, a negative 5 and a 9, that's going to be a 4. So a sub n is equal to 5n plus 4. Easy enough, right? So let's step it up a little bit. So find the nth term of the arithmetic sequence with the fifth term being 19 and the ninth term being 27. Now there are multiple ways that people always go about doing this. I'll show you the 2 ways that are usually the most popular. If you have another way of doing it, then that's fine too, but I will show you the 2 most popular ways that I have seen. All right, so if we know a sub 5 is equal to 19, right? But really, let's write it in terms of an arithmetic sequence. So really, a sub 5, that would be a sub 1 plus how many common differences would you have to add to go from a sub 1 to a sub 5? Well, it would be 4d. goes back to our equation that I derived on the other side. And I know that that's 19. Okay, a sub 9, that is a sub 1 plus how many d's? N minus 1, which is 8d. And I know that this is 27. So if you focus on this right here, what do you really have? You have a system. And so I'm going to combine these two equations. I could just, I'm just going to subtract them, I suppose. So that's, if I subtract these, I'm going to get a negative 4d equals a negative 8. And so that means d equals 2. Great. But so I wanted you to find the nth term of the sequence. So really I'm looking for an equation. So d is part of that equation. And what am I missing in the equation? I need to find a sub 1. Right? So to find a sub 1, well, I can go back to either equation here. I'll just go to this one right here. And so I know I have a sub 1 plus 4 times my d, which is 2, equals 19. So really a sub 1 plus 8 equals 19. So a sub 1 is equal to 11. All right, and so just to wrap it up in my equation here, I have a sub n equals, following the equation we derived on the other side, your first term, which we just established was 11, plus n minus 1 times d, which we figured out was 2. And again, we like this simplified. So distribute in, I'll get 2n, a negative 2n, and 11 would be 9. And there's your answer. If that works for you, great. But I'll also show you another way that people have used over the years. Okay, so I know that a sub 5 equals 19, and I know a sub 9 equals 27. Okay, so you can choose either of these, but if I go with a sub 9, I know that I want to write a sub 9 in term, actually it would be kind of weird to start with a sub 5, so I take the larger one, the a sub 9, and I want to write it in terms of the smaller a. So a sub 9 would be equal to a sub 5 plus 4d. So if I'm at a sub 5, right, I got to add 4 of those common differences to get to a sub 9. Okay, so hopefully you follow that. Now it's just substituting in what I know. Again, not pretending I did everything on the left already. So a sub 9 is 27, and then a sub 5 is 19. So this is solving for d. I would subtract 19 to get 27, divide by 4. Did I say to get 27? Sorry, 27 minus 19 is going to be 8. Divided by 4 is 2. Okay, so again, important information that I need. All right, then I go to the a sub 5 equation. All right, and so I know it's going to be, d is always multiplied by some n. So it's going to be 2n plus some number that I need to figure out. Again, the 2 comes from your d. Okay, so let's substitute in what I know. A sub 5 is 19, and I just found out that I didn't just find out, sorry, my n is 5, and so I'm solving for my c. C is just some constant, it's not part of the other equation. So I find out that c is going to be 9. So what does that mean? A sub n is equal to my d, which was 2n, plus my c, which was 9. It's another way to get that equation. So either way, I showed you both there. All right, the next thing I need to show you is just a kind of like a mini proof, which I already, of course, wrote out. So it's a proof of the equation for the sum of the first n terms of an arithmetic sequence. So S stands for sum. So this stands for sum of the first n terms. So that means you'd have to add up a sub 1 plus a sub 2 plus a sub 3 all the way up to a sub n, which we could do for a certain amount of numbers. But if we give you a ridiculous amount, that's something we're not looking for you to just say plus, 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 plus. All right. Another way to think about this, taking this equation and writing it in terms of a sub 1s. So a sub 2 is the same as a sub 1 plus d. A sub 3 is the same as a sub 1 plus 2d plus dot 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 a sub n. The equation that we already established is a sub 1 plus quantity n minus 1 times that d. Okay, so I have this boxed in because I'm coming back to it. Another way we can think of S sub n, okay, just in terms of n's, going the other opposite direction. Right here we're ascending from 1 to n, here you're descending. So if we have a sub n plus a sub n minus 1 plus a sub n minus 2 plus dot 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 all the way down to a sub 1. You're like, why would you do this? Well, this is proof world here. So I could rethink again this equation in terms of a sub n's. A sub n minus 1, remember that's the term previous to a sub n. That's really a sub n minus d. A sub n minus 2, that's 2 terms before a sub n. So that's a sub n minus 2d, all the way down to a sub 1. All right, now using these two equations that I boxed in, we're going to add them together because we have the two, they're both solved for S sub n. So S sub n plus S sub n is 2S sub n. A sub 1 plus A sub n is quantity a sub 1 plus a sub n. I feel like I'm speaking another language. Then you take your second term, you have a sub 1 plus d plus this term here, a sub n minus d. What happens with your d's? They cross out, and once again, you're just left with the a sub 1 plus a sub n. And again, if we take the third term in, again, you're adding them. So you have a sub 1 plus a sub n, and then your 2d and your negative 2d cancel. And you can do this for every single term all the way down here, right? The quantity n minus 1 times d is going to cancel here with the negative, and you'll be left with just a sub 1 plus a sub n. So really, how many of these same terms are we adding up? The a sub 1 plus a sub n's, they're all the same. You have n of them. Okay, and so the equation that we will be using, if you solve this for S sub n, divide both sides by 2, it's n times the quantity of a sub 1 plus a sub n, all divided by 2. This is for, again, the sum of the first n terms of your arithmetic sequence. So that's kind of just a proof, so I know you were super interested in where that came from. But here it is. So one type of question that we could ask you, remember we did summation notation, gosh, was it last section? Yes, all your sections run together in my head. All right, so if I asked you to evaluate the summation from 1 to 20 of 7n plus 1. Okay, so again, I'm not looking for you to actually figure out what term 1, 2, 3, 4, all the way up to 20 is, and then add them together. That's not, if we were in class and we were having assessments, that would not get you credit for this. We want to use the equation here. And how do I know I'm adding? Because this says, remember this means to add, summation. So n stands for the number of terms. So if I'm going from 1 to 20, how many terms are there? Okay, there's 20. All right. And then my first term, because that says a sub 1, so I have to put 1 in. That represents your first term. 7 times 1 is 7. Plus 1 is going to be 8. So that's your first term. And then I need a sub n. So my last term is 20, a sub 20. So it's going to be 7 times 20 plus 1, which is going to be 141. And it says to divide by 2. So if you put that into your calculator, you should get 1,490. So that means if you add up for this expression here, 7n plus 1, the first term all the way up to the 20th term, you're going to get 1,490. And I know you can't believe it, but there's only one more example left. I know, my other lessons, it's just been a lot. There's not too much in this section, which is a nice break for you. So number 5, the last one, find the 15th partial sum of the sequence. This one's a little different because you're actually given the sequence and not the kind of formula this time. So 2, 5, 8, 11, etc., etc. Okay, so we have to just check and make sure that this is an arithmetic sequence, and I find the difference between all these, and it's 3 every time. So that's great news. So little notes to myself. I know that a sub 1 is 2. And I know that a sub n is a sub n minus 1. Another phone call. I'm going to have to pause and call you back. Not call you back, I'm going to have to finish this in a minute.